Okay, today is going to be an introduction to a logarithm. And the purpose of logarithms is to be able to figure out what an exponent is. So I want to start off with a little review. This isn't on the notes or anything, but I think this would be kind of helpful to move forward. So let's look at a problem similar to, if you watched yesterday's videos and you worked on the assignment, this problem should look familiar to you. A town of 50,000 people is losing people at a rate of 3% each year. We got three questions we want to address with this. Question one is, what is an exponential function that models this pattern? The second one is, what will the population be after 10 years? And the third one, and this is something that we didn't do in the previous section, is how many years will it take the population to be 10,000 people? So this one's a little bit different because we're trying to figure out a time, and we hadn't done that yet. So let's start with the beginning. First of all, we have to understand that because it's losing, it's going to be a decay model. And therefore, we want to use the function capital A equals lowercase a parentheses 1 minus r to the t power. Since it's losing people, that's decay. And we want that number to be between 0 and 1. So to get that number to be between 0 and 1, we find the rate. That's 3%. And we subtract that from 1, but we got to convert that to a decimal because you don't just do 1 minus 3, that's negative 2. You don't want a negative in there. So we take that 3% and we divide it by 100. And that's basically moving the decimal over, 3.0 is 3. So if you move it over to the left twice, it should be 0.03. So we want to subtract that from 1. Our A value, that's going to be your starting amount. That's 50,000. And so your function would be A equals 50,000, 1 minus 0.03, raised to the t power. And 1 minus 0.03, in the calculator, it's going to say 0.97, because that's really 100% minus 3%, which is 97%. So your function would be A equals 50,000, parentheses 0.97, raised to the t power. So the question for B, which is evaluating it, we want to know what the population is going to be after 10 years. That's your t value. So we'll take your t and plug that in and see what you get. That's going to be 50,000 times 0.97. I didn't put the 0 here. I don't care if you put the 0, but know that 0.97 and 0.97 represent the same number. And that'll be raised to the 10th power. That's something I'll need a calculator for, so let's see, 50,000, parentheses 0.97, exponent 10. So 36,871.2. It's population, we're talking about people, so I don't really have a need to round that to 0.2. So we'll say about approximately 36,871 people. And that's where we stopped yesterday. So today we want to address the question, how many years will it take the population to be 10,000? So we want to predict a time that gives us a final amount of 10,000. This would be like your capital A. So really we're solving this equation. 10,000 equals 50,000 times 0.97 raised to the t power. And for that, we can do a couple things. We can estimate. 10,000 equals 50,000 times 0.97 to the t power. We can certainly plug that in and kind of play around with the numbers. So let me do 50,000, 0.97 raised to, and we can't put t in decimals, so we'll put x. So how many years? Well, we know 10 years is going to be 36,871. So let's try raised to the 20th power. And that doesn't decrease it down to 27,000, but we still got to get it down to 10,000. Remember that we wanted it to equal 10,000. So let's try 30. If you don't know how to solve this with what we're going to learn, later in this lesson, then this is absolutely, a way to start it, just kind of guessing and checking. All right, 30 is a little bit too low. We'll bump that up. Let's try 50. Seems like I'm going kind of slow, so let's raise it to the 50th power. And that's pretty darn close. We're almost at 10,000. We probably got to go a little bit higher than 50, so let's try 55. My guess is it's somewhere between 50 and 55. So 55 is a little bit too much. Try 54. 53 is pretty close, 9,951. So it looks like between 52 and 53, it's going to hit that 10,000 mark. And we can play around with the decimals as much as we want. If we do 52.5, 0.6, 0.7, 0.8. 52.8 is pretty close. That's a lot of guessing and checking. So another way we can do it is using a graph where we can say 50,000, 0.97 raised to the x power. And let's take a look at this graph for a minute. Now, since your starting value is 50,000, it's going to be starting pretty high on the graph. And you notice how that decreases pretty sharply. Now, I don't want this graph to look quite like this, so I'm going to adjust the window. If I had this in here, if you want to adjust the window, let's say you want to make the x-axis scale a little bit wider. You can hit the graph settings up here at the wrench. And let's just make the x-axis go from, what was I at, 50 something? Let's do negative 100 to positive 100. And we can even count it. So I can count it by, tenths if I want. So now you can see the graph, starting at 50,000, and at 10, it's about 36. Here's 50. If you want to know the exact, what you could do is in a new line, you could say y equals 10,000. Then you get a flat horizontal line. And right there where they hit, they meet at 10,000, but that x value, 52,839, is the answer to the question, 52.839. So about 52.8 years is good enough to round. But there is another way to do that, and that's using a logarithm, and that's what we're going to talk about today. But let me just kind of show you right now what we can do in the calculator without getting into specifics of why. I'll get into that later when we solve them. But there's something called a log, and you can get this down here. If you click on the calculator on Desmos and go to functions, there are logarithms. If I go to miscellaneous, there's a log and there's a log base A. I'm going to hit log base A. Now, the base is actually the same number as the base and the exponent. So that number 0.97 will go down there. You're like, what is this thing you're talking about here? I'll explain a little bit later. The number inside the parentheses is what your two numbers you had in this equation divide to. So 10,000 divided by 50,000. What is that? Why does that work? Well, we'll get into that in the next lesson, or later in the lesson and in future lessons. But just for right now, you can see this can be evaluated using something called a logarithm, and log on the calculator is short for logarithm. So that's a quick introduction to what we're doing, and I'll get into the specifics of what a log is later in the lesson. So I hope this was helpful, and see you in the next video.